All right, this meeting is being recorded. Okay, so you should have 1 mole of propane is equal to the moles of everything else. And I got 5 moles of O2, 3 moles of CO2, 4 moles of H2O. So all you're doing when making a mole ratio is you are targeting one of the substances and comparing it to another substance. It's basically like a ratio. For every 1 Jade, I have 1 Nick in this class. For every 1, well, actually, for every 1 Derek, I have 2 Carsons, Cheeseman and Dye. So it's just a ratio. That's why it's called molar ratio. So the next one, I want you to compare oxygen to everything. You have 5 moles of oxygen. Jade, how many moles of propane are there? Oh, why am I not writing moles? 1 mole, C3H8. Max, I have 5 moles of oxygen. How many moles of carbon dioxide are there? Correct. And Kendall, I have 5 moles of oxygen. How many moles of water do I have? That's it. All you're doing is mole ratios. Okay, Colby, I have 3 moles of CO2. How many moles of propane are there? Nick, 3 moles of CO2. How many moles of oxygen?
5.
And 3 moles of CO2. Let's go to Brennan. How many moles of water?
4.
All right. So it sounds like you guys get it. I'm just going to go ahead and do water real quick. 4 moles of H2O is equal to 1 mole of propane. I should probably do this in a different color. 4 moles of H2O is equal to 1 mole of propane. 4 moles of H2O is equal to 3 moles of, wrong one, 5 moles of O2, and 4 moles of H2O is equal to 3 moles of CO2. Perfect. So that's all you had to do. That's it. Write every possible mole ratio. Done. Now let's actually do a problem. Let's see if you guys can be put to the test. Example. The decomposition of potassium chlorate, which is KClO4, is sometimes used to obtain small amounts of oxygen in the lab. Number 1, write the balanced equation, or the balanced decomposition reaction, actually. I want to see if you guys can come up with this with only being given a few of the substances. All right. So we have KClO4. That is a solid. Will be broken down to KCl. Can anybody tell me what is the name of KCl? Nicole? That's it, calcium chloride. Well done. And then we have oxygen gas. All right. I will never tell you don't make your little scoreboard. If you have to use it, use it. But the goal is to try to get so good at balancing you guys don't need it. So take a look, survey this problem, and we need to balance it. I noticed that there's 1 potassium on each side. There's 1 chlorine on each side. But there's 4 oxygens on the left. There's 2 oxygens on the right. We got problems. So, anybody know how we can, did I get that right? KCl, oh, my bad. I'm a doofus. Big fat doofus. It's not KClO4, it's KClO3. Dirt. My bad. That's on me. Colby told me to write it. All right. Now we're cooking. Okay. We have 3 oxygens on the left. We have 2 oxygens on the right. You guys have dealt with this problem before. What do you do when you have 3 and 2 of something? What is the common multiple? Right? 6. So how do we get the oxygens on the reactant side to go from 3 to 6? Put a 2 coefficient in front. Okay? And how do we get the oxygen on the product side to go from 2 to 6? Francis? I'd put a 3. I agree. Sweet. The oxygens are fixed. But Jade, we have a potassium and chlorine problem now. Jade, right now, as it stands, how many potassiums and chlorines, for that matter, are on the reactant side? And how many are on the product side? So what do you suggest we do to the potassiums and the chlorines on the product side? What is that to? Is that called a coefficient or a subscript? Very good. There it is. Balanced. Great. Perfect. Wonderful. Any questions on balancing? So the total ratio is 2 to 2 to 3. Now here's the tedious part. Write all mole ratios. Go ahead and write them out, guys. No peeking, looking up. Write down the balance equation on your paper. Show yourself that you can do this on your own. You don't need to depend on me. Jay, do you like saying bless you during a test when someone sneezes?
No.
It's like being a little teenage rebel. The teacher told us to be quiet, but I'm going to say bless you! And they can't say anything because I'm being nice. Ha! I'm so rebellious. Okay, no peeking. No looking up. And now, Jade, if you watch this video on YouTube, this little exchange you and I just had is on there forever and ever. Yeah. So people like Carson Cheeseman and Jude are going to be, in Easton, going to be watching this lesson and go, the heck is he talking about? And why did he just say my name? Oops. All right. Okay, there's all the mole ratios. You should have 6 of them. Now, the fun begins. Max, you ready? See your calculator. Well done. Arshawn, are you ready? I don't think so. Is that? What do you mean, why not? So I said so. All right, if you say so. Here we go, guys. Section 2. You now have the basic tools to do this next part. We're graduating. Here we are. Stochiometric, fun word. Calculations. Oh boy. All right. You are given the problem 2 moles of potassium, a solid potassium, reacts with 2 moles of liquid water. This will yield 2 moles of potassium hydroxide. It is aqueous, so it dissolves in water. And 1 mole of hydrogen gas. And I cannot stress to you guys enough, I've been saying this all year, when you do not see a number, the number is 1. So there's 2 moles of potassium, 2 moles of water, 2 moles of potassium hydroxide, 1 mole of hydrogen gas. Hydrogen gas is H2. Here is your question. How much hydrogen is produced if only 0.400 moles of potassium is used? Question mark. Okay. Now, guys, this is called a mole-to-mole conversion. How do I know that? Because whenever you see the words how much, that right there means moles. I'm giving you the keys to the car. Where we drive is going to be up to you. Now, my known value, Mr. Derek, can you please read the problem to yourself and tell me what is the known value in this problem? This is not a chemistry question I'm asking you. This is a reading question.
The known value is that there's only going to be 0.4 moles of potassium used.
Good. I'm glad you didn't just stop at the number. He says 0.4 moles of potassium. Okay, Derek, can you tell me in the chemical equation,
Yes.
where is potassium, a reactant or a product?
It is a reactant.
Good. I'm going to highlight it right there. There's the potassium. Now, Scout, can you read the problem and tell us what is the unknown value? Like, what are we trying to find? What is the unit of measurement we're using, and what substance are we trying to find?
How many moles of hydrogen?
Good job. How many moles of hydrogen? Now, Scout, take a look at this chemical equation that's up above. Is hydrogen a reactant or a product? Good. Okay. Are there any questions on what we've done so far? All we've done is we've read the problem, we've identified our known value, and we've identified our unknown value. So I'm going to write that down. This really, I don't know about you, but this really helps me keep my thoughts in order. My known value is 0.400 moles of potassium. My unknown value is X moles of hydrogen gas. So if you all look at the equation, we don't care about water and we don't care about potassium hydroxide. We don't care. We don't care. We only care about potassium, which I highlighted in yellow, and hydrogen, which I highlighted in green. Now, this problem is a mole to mole conversion. This type of problem is the easiest because it only requires one conversion. And that conversion is going to be molar ratio. Okay? So, what do we always start off a problem with? Your known value or your unknown value? I mean, that's pretty simple. That's your known value. So let's write it down. 0.400 moles of potassium. This is one conversion. So all you have to do is write one conversion table. You need to look up at your chemical equation and you need to identify what is the mole ratio between potassium and hydrogen. Now, Derek, as I bragged on you earlier, you were killing this, so let's see if you can live up to the hype. What is the conversion? What is the mole ratio between potassium and hydrogen in that chemical equation?
2 to 1
You nailed it. Where do I put the 2 moles? Do I put 2 moles of potassium on the bottom or on the top?
on the bottom.
Now, if I were not a big expert in chem and I know what it feels like being in high school, I'd be like, wait, where'd you get that from? I got it from here. Whoa. Yep. The very first substance in the chemical equation. It says right there, 2 moles of potassium. And then he says on the top, we need to put 1 mole of hydrogen. Now, if I was sitting in a chem class, I'm not the best at chem. I think, well, where'd you get that from? We got it right here. And when I told you there is no number in front of it, what is the number? That's 1 mole of hydrogen. This is our conversion. This is our mole ratio. Moles of potassium cancel out. So this is a division problem. What is 0.4 divided by 2? 0.200 moles of hydrogen. That is your answer. Now, I'm going to give you guys one all on your own. Time for baby bird to fly. I'm just going to cut to the chase here. You have the balanced equation of the combustion of propane. You've done this already. C3H8 gas plus 5 oxygen yields 3 CO2 plus 4 H2O. Okay, that is the combustion of propane. You are being asked to find, here we go, how many moles of CO2 is produced when 10.0 moles of propane is burned in excess oxygen in a gas grill. I'll give you guys about 2 minutes to do this. I'm not going to do anything more. You take over. We'll reconvene in a couple minutes. When we get, if there's going to be semester exams, and we'll do it during our review. All right. Kevin, can you tell me what the known value is?
10 moles of propane.
Is propane a reactant or a product?
It's a reactant.
Tim, what is the unknown value? What is it going to be measured in? Good. Is CO2 a reactant or product? Now, problems like this, and any problem for that matter, is meant to get you guys to second guess and to think. It says burn in excess oxygen. You don't care. Oxygen is just letting you know that there's plenty of oxygen. So your known value is 10.0 moles of propane. Your unknown is X moles of CO2. So you are converting from moles of propane to moles of CO2. This is a mole to mole problem. Now, how many conversions do you have to do here? One conversion. That's it. This is what stoichiometry is. It's a fancy technical way of saying converting. So you start off with your known value, 10.0 moles of propane. And who have I not picked on today? Kayla. What is the conversion between moles of propane and moles of CO2? Three to what to one to of what? Say the whole thing. Three of what to
3 of C3H.
three. When you said three of C, where do you see three?
Oh,
I don't see any number in front of that. Do you?
and that's 1.
One what?
1 C.
What's the unit of measurement? Little subterranean mammal. 1 mole of,
C3H8.
that's propane. So 1 mole of propane is equal to,
3 moles of CO2.
good. Where do I put the 1 mole of propane? On the top of my conversion table or on the bottom?
At the top.
Why?
Actually, the bottom.
Okay. I didn't want to say anything. I want to see where you're going with that. Why the bottom?
Because it was out.
Bingo. Good save. 1 mole of C3H8 is equal to 3 moles of CO2. So, Kayla, I think you can do this in your head. What is 10 times 3?
30.
30.0 moles of CO2 should have been your answer. Are there any questions? That is a mole-to-mole problem. All right. So we're going to stop the notes there, but you guys still have 25 minutes left in class. So we still have a ways to go, but I want to stop now so you guys can really feel confident in what you're doing. So I'm going to switch over to Canvas. And if you're at home, I'll share my screen with you. I'm going to go to my third period chem. Scroll down to Unit 10, which is open now. I'm going to go to assignments, which is not open for you guys. And I want you to work on this worksheet in class as practice. You guys will get participation points just for doing this. You have 10 problems here. I'm going to zoom in. And you can see 3 at a time. If you need to stand up and write it down and go back to your desk, you can. I want you to work on these problems. The fact that you're sitting here in class, I'll give you credit, or let me rephrase that. You will have earned credit, but this is valuable practice. You have a test next week already, so they come up quick. If you have any questions, that's what I'm here for. I want you to try on your own to see if you can get these done. Yes, Carson. You figured that out. Look at them and you see. Well, that's a good observation. Are they balanced? You do need to make sure they are balanced. He asked, are they balanced? That is something you guys can see for yourself. Yeah.
So do you just want us to write these down and then write the next one down? Or just
I want you to solve these. So Carson had a very good question. Are these balanced? And I said, you figure it out. You guys need to be able to look and see if they are. And if they're not, fix it. They're asking us to cut down on copy paper, so this is what we call improvisation. I'll let you guys do these 3. and then I'll work them out with you. Then we'll move on to the next set of 3.
The first one, is it 2 separate equations, one for sodium and one for chloride? So
No, you have 2 reactants, 1 product. You have to balance the equation. When it says so, how many moles of sodium? Oh, I see what you're saying. Sorry. Yes, you have to do 2 separate ones. Yes. Okay, I'm going to start working out 1, 2, and 3 on the whiteboard. Check your work. Okay. All right. Got the first three for you. So, for those of you watching at home, the balanced equation for number one is a 2:1:2 ratio. So you're doing two equations. The answers would be 0.043 moles of sodium and 0.013 moles of chlorine gas. Yes, Carson.
I think that instead of including 0.013 mole of chlorine 2, it's 0.022.
Let me check. Okay. So 0.043. The first one is 0.043 moles of sodium, right?
Yeah.
Divided by 2. I got 0.02. Oh, I see what I did. My bad. 0.023, right? Is that correct? 2.2. Oh. Man, what's wrong with me? Right, 2.2. Excuse me, I'll fix it on the whiteboard. 0.022. So everybody got 0.022 moles of chlorine? Now, Carson, real quick, you said chlorine 2. It's just chlorine gas is diatomic. Have no fear of ice cold beer, so it's always Cl2. All right, next one. The ratio is 2:1:1:2. So you are converting sodium hydroxide into sodium sulfate. So the answer, and correct me if I'm wrong, you just did. I'm not perfect here. 0.063 moles of sodium sulfate. Do you guys get that? Great. Next one, you're converting rust into iron 3 oxide. The ratio is 4:3:2. So your answer should be 1.12 moles of iron 3 oxide. You get that? Great. All right, let's move on to number 4 and 5. Yes.
When you're saying, like, when you're stating the names of the equation, why would you not say iron 3 when iron is outside? And what you said-
Iron 3 represents the charge when it's part of a compound. It's a positive 3 charged iron in the compound.
Not charged when it's alone.
When it's by itself, you're just going to consider it an atom. Okay, guys. Numbers 4 and 5. Go ahead. Read the directions for what it says to do from 5 through 8. This is all practice. This is like learning to ride a bike without the training wheels. Okay. Number 4 up on the board. We'll put it on the computer in a moment for those of you learning online. 5. All right, 4 and 5 are up. So number 4, the balanced ratio should be 2, no, 1, my bad. 1 to 2 to 2 to 1. You were asked to do all 3. You guys had to convert your known value, which was copper, into everything else. So you should have 3 answers. For silver, I got 7.26 times 10 to the negative third moles of silver. Did you get that? For silver nitrate, I got 7.26 times 10 to the negative third moles of silver nitrate. Did you get that? And for copper 2 nitrate, I got 3.63 times 10 to the negative third moles of copper 2 nitrate. Did you get that? If you did not, this is when you ask, not when you're doing the test. So this is all about figuring it out, going through the motions. Is everybody okay with number 4? Let's check out 5. And this will be the last one. You don't need to do anything past 5 because we're running low on time. It says determine the amount of each reactant needed in each product produced to produce the following. So you're given sodium sulfate, which is this guy. The ratio, I think, is 1 to 2 to 2 to 1. Did you get that ratio? 1 to 2 to 2 to 1. All right, so for my answers for sulfuric acid, which is that guy, H2SO4, I got 1.06 times 10 to the negative first moles of sulfuric acid. Questions? For the next one, sodium cyanide. CN is cyanide, if you didn't know that. I got 2.12 times 10 to the negative first moles of sodium cyanide. And then for the second one, I got 2.12 times 10 to the negative first moles of hydrogen cyanide, which is cyanic acid. Yes, Arshan.
If like the things have the same molar ratio, can we just write it as the same thing?
If it's 1 to 1 or 2 to 2, yeah.
No, but if it's like 2 of the things both have a 1 to 2 ratio with the first, can we just write the same thing?
You need to show your work. Okay? Now, ladies and gentlemen, here's what I would like you to do, and this is what I want you to work on at home. You can currently see your unit review. What I would like you to do is I want you to work on your homework problems that get up to this point, mole to mole conversions. Tomorrow we're going to do mole to mass and mass to mole, which is 2 steps. So this is take one thing at a time. I know how chemistry can be. I don't want to overwhelm a system that already is overwhelmed. Work on your homework from your unit review that gets up to this point, mole to mole ratios. If you have any problems, bring them to class tomorrow. And then when we're past that, we're going to get into mass to mole and mole to mass, which is a 2-step procedure.